Dear students, now we are going to use graphical analysis of motion. As we are studying rectilinear motion, in rectilinear motion, three types of graphs are used in motion analysis. We'll see that these graphs are quite helpful in solving various kind of problems of rectilinear motion also. These three types of graphs are displacement versus time graph. The second is velocity versus time graph. And the third is acceleration versus time graphs. We also discussed the variant of displacement time graph as distance time graph. We'll also discuss distance versus time graph. We'll also discuss speed versus time graph because some particular category of problems are also asked on distance and speed versus time graphs. But we don't need to spend much time on these at slight variations of displacement and velocity time curves. Let's discuss these one by one. Now, if we talk about displacement versus time graphs, these are also known as position versus time graphs. There is no difference between position versus time and displacement versus time graphs. Say for a given rectilinear motion, we draw the displacement time curve like this. So this is the curve according to which the position of a particle varies with time. So its function is given as x is equal to f of t. In this situation, at any instant of time t, we can directly get the position of particle by using this curve or by substituting the value of time in this function. So if this point is P, we draw a tangent of this curve at this point P and say it makes an angle theta with the time axis. So we can simply state the slope of the curve at point P can be written as dx by dt, which is equals to tan theta. And we all know that dx by dt can be directly written as instantaneous velocity of the particle at this position P. So by a displacement time graph, at any point if we want to calculate or we want to evaluate the instantaneous velocity of the particle, we just need to find out the slope of the curve at that point, and the slope will directly give us the instantaneous velocity of the particle at that point. So in this situation we can see that this tangent makes an acute angle with the time axis. So here we can simply state the velocity Vp, which is tan theta, will be a positive quantity. If we talk about the decreasing part of the curve at a point Q, if we consider a tangent, you can state this angle theta dash will be an obtuse angle. So at point Q, the instantaneous velocity can be written as tan theta dash, and tangent of the obtuse angle can be written as a negative physical quantity. So in the decreasing part of curve, we can say with time the displacement is coming down or displacement is decreasing, or as if we talk about the position of particle, it is moving towards origin. So we can state vectorially the velocity will be negative. We can also talk about various situations like for a practical situation, if say a particle moves in such a way that first it accelerates, then it moves uniformly, and then say it retards. Initially say it was at rest, and finally also say it will come to rest. So first it accelerates, its velocity increases, then it moves uniformly, and then finally it comes to rest. Now in such situations, if a particle is accelerating, we can simply state the slope will first increase and then it moves uniformly. That means its slope remains constant, because you can see the slope is giving us the instantaneous velocity. And if it retards, that means the slope decreases and finally it becomes zero. So if we draw the displacement time graph of such a motion, we can state first slope is increasing, the curve goes like this, you can see, continuously the angle with the tangent makes with the time axis is increasing. And then say for a time t1 it is accelerating, and from time t1 to t2, or you can say for a duration t2, it moves uniformly, so we can draw a straight line. So here the whole slope for the duration t2 remains constant, then it retards. So you can simply draw a curve like this, which is for another duration, say t3. Now in this situation finally you can see the slope becomes 0, and earlier also slope was 0. This is the curve which is representing a motion where a particle first accelerates, then moves uniformly, and then retards. Similar to this, if we just consider an experimental situation like say this positive direction of x-axis, from origin a particle starts, it moves with a velocity v, it goes up to a particular position in a time t1, then for a time t2 it remains at rest over there, and then it comes back to origin with the same velocity v in a time t3. So from 0 to t1 it was moving uniformly up to this position, say we write maximum displacement xm. For a duration t2 it remains at rest, and then for at time t2 it will start moving in opposite direction, and at time t3 it comes back. Now if we draw the position versus time graph for this motion, you can simply state at t equal to 0 particle starts with a uniform velocity. Uniform velocity means the slope remains constant. Here we can write tan theta is equals to v. This was the time t1 for which the particle was moving uniformly. Then you can state up to time t2, or for the duration t2 minus t1 it remains at rest. So its position remains constant, that is at xm. And then it will start coming back. So the velocity is in opposite direction, or we can say when it was moving toward right, velocity was positive and now velocity is negative. So it comes down, and at a time t3 it will reach the original position back. So you can simply state again x becomes 0 and say this angle is theta dash. So we can again write tan theta dash is equals to v. Now this angle will be 180 minus theta, and we can state the tangent of obtuse angle is negative. So this angle theta dash can be directly taken as the angle by which we can directly calculate the negative slope. So this is the curve which is drawn for uniform motion, then rest for some duration, and then again uniform motion in opposite direction. Now if similar, this is the curve which we call as position time curve or position time graph. If a similar graph is drawn for distance time, let us draw distance time graph for the same motion of particle when it is moving, then taking rest and then coming back. So you can simply state, if we talk about displacement, it first increases to xm and then decreases to 0. But when we talk about distance, we can state distance is continuously increasing, because from here to here the distance is xm, and when it comes back the total distance traveled by the particle will become 2xm. The only difference in position time and distance time graph can be taken that distance time graph, if this is taken as distance time graph will never come down. Say it will first increase to a position of xm for a time t1, then it remains at rest up to a time t2, and then again it returns back. But if we talk about position, it is coming down, but if we talk about distance, it is still increasing. So the same graph can be drawn in reverse direction. So up to a time t3, it will be able to cover a distance of 2xm. This is the distance time graph for the same motion. You can simply state, if we are having a displacement time graph, then for those portions of displacement time graph where the curve is coming down, You can draw the mirror image with respect to time axis in upward direction, that will become distance time graph. If we talk about velocity time graphs, these are the graphs relating velocity with time. Say we draw a graph in velocity and time for motion of a particle. This graph is drawn for the function of velocity, how it varies with time. At any position of this graph, similar to that of displacement time graph, here if you draw a tangent and you find out the slope of this graph, say at point x, we can simply state this point is relating time with the velocity. And here the slope can be written as dv by dt, or it can be written as tan theta. And here the slope is giving us the acceleration of particle at the position x. So always remember that the slope of velocity time graph gives us the instantaneous acceleration. And if a slope is positive, like here you can see acceleration at point x, it is tan theta and theta is acute angle, this can be taken as positive acceleration. Positive acceleration means the velocity and acceleration have same direction, and you can simply state the speed of particle is increasing or the magnitude of velocity is increasing in this case. When we talk about the decreasing part of the curve at any position, if we draw a tangent, you can see the angle theta dash is obtuse. So this is the point y. So we can say acceleration at point y will be tan theta dash, which is a negative quantity. So here you can see the velocity is decreasing, so acceleration we consider to be negative. So be careful about this situation where we are finding the slope of velocity time curve as acceleration. Along with this, we have already studied in calculus that area under a curve can be given by for between two coordinates on time axis, say t1 and t2. If we find out the area of this curve, so area under the curve can be given as integration of v dt from t1 to t2. Here you can see this integration of v dt will be given as displacement only, because if we talk about v into dt, it is the displacement covered by the particle during the time dt. So if we calculate the total displacement of particle from point t1 to time t2, it can directly be given as integration of v dt from t1 to t2. It will give us the displacement of particle from t equal to t1 to t2. This is another advantage of using velocity time graph, that from velocity time graph using slope we can find out the instantaneous acceleration of particle, and finding out the area under the curve. Like say we find out this area by using integration, this area under the curve gives us the displacement of particle between two given time instants in the given situation. If we just have a look on the motion situation as shown in the velocity time graph, a particle moves in such a way that t equal to 0, its initial velocity was 0. First velocity increases, that means it was accelerating, and then after some time it will decreases and again it becomes 0 at time t1. Then velocity becomes negative. You can say this is the negative direction of velocity, and velocity becomes negative, that means particle has returned in opposite direction, and at time t2 again its velocity becomes 0. So in such situation you can say from time 0 to t1 the area between the curve and the time axis is above the time axis, this is positive, and from time t1 to t2 you can see that this area is below the time axis, so this is written as negative. Say this total area is S1 and this total area is S2. So we can state total displacement of particle from t equal to 0 to t2 is total displacement can be written as S1 minus S2. But when we talk about distance traveled, you can always write distance traveled is equals to S1 plus S2, because S1 is the distance traveled in positive direction and S2 is the distance traveled in opposite direction. So displacement will be S1 minus S2, but when we talk about distance traveled, it will be S1 plus S2. So be careful about such situations while drawing velocity time curves. Similar to this, we can also talk about acceleration time graphs, but there is nothing much to discuss about acceleration time graphs. Like if we draw acceleration time graph for a given motion, you can simply state an acceleration time graph. If we find out the slope, that a slope will give us the rate with which the acceleration is varying, which is not of much importance in our limitations or the syllabus we are analyzing the things. But when we talk about the area under the acceleration time curve or area between the acceleration time curve and time axis between two instants t1 and t2, certainly it is of quite importance. Like if we find out this area is say a, so this a can be written as integration of a dt from time t1 to t2. This a dt will give us net change in velocity of particle from t1 to t2. This is something which is important for us to keep in mind, that integration of a dt from t1 to t2 gives us the net change in velocity of particle in going from time t1 to time t2. This you should always keep in mind.